Alright, so we're going to take a look at solving a system of equations using the substitution method. The idea behind this method is that right now we have this system of equations and we have two equations that each have two unknowns. So we can't really solve this equation as it is because there are two variables. We can't really solve this equation as it is because there are two variables. Now, knowing that we know how to solve an equation when there's one variable, the idea behind this method is to try to set up one of the equations so that it's in terms of only x or only y, or only one of the variables, whatever they are. So this first equation is saying that x and 2y minus 4, those two expressions, they have the exact same value. So because they have the same value, we can replace one with the other anytime we want to. It's kind of like if you have a $20 bill, you could replace that with a 10 and 2 5s, or 4 5s, or a 10 and a 5 and 5 1s, or whatever you want to. So because I know that x and 2y minus 4 have the same value, that means in this second equation, anywhere I see an x, I can replace it with 2y minus 4. So that's exactly what I'm going to do. Right here, I see I have an x. And what I want to do is take this other expression, 2y minus 4, which I know has the exact same value, because that equal sign says it does, and I'm going to replace it. So I'm going to take this expression, 2y minus 4, and substitute it in for x. And only going in for the x. Some students want to replace the 2 also, but this just says x equals 2y minus 4, so that is going just into the x. Essentially, you're going to take that second equation and you're going to write it exactly as it is, except for one change. Instead of the variable x, you're going to replace it with that quantity, 2y minus 4. Everything else you're going to bring down just as it is. You're going to bring down that 2, you're going to bring down that plus y, that equals 12. The only change is that you swapped out, instead of x, you replaced it with something that is known to be equal. This is a good thing because now I have an equation that only has one variable and we know how to solve that. So you go ahead and distribute that in, so we have 4y minus 8 plus y is equal to 12. Got a couple of like terms, go ahead and combine those. So we have 5y minus 8 is equal to 12. Go ahead and add 8 to both sides. So 5y is equal to 20. Divide it all by 5, and y is equal to 4. Now that I know what y is, we also need to know what x is. Because we have an equation in x and y, the solution to that equation is an ordered pair of an x and y. Now that I know y, I need to take that 4, and because I know that y and 4 are the same thing, I can replace any y I see up here with a 4. You can replace it in either equation, but knowing that our goal here is to find out what x is, and x is already solved by itself in that first equation, it makes most sense to substitute 4 into that y, because then we'll have less work to do to find x. So you're basically going to replace that y with the value that we found it to be, which is 4. And that's going to allow you to solve for x. So x is equal to 2 times 4 minus 4, which is 8 minus 4. So x is also 4. So our solution here is the ordered pair 4, 4, where x is 4 and y is 4. Now the best thing to do here is check it and make sure it works. The solution to a system of equations is an ordered pair that works in both equations. So that's exactly what we're going to check. Does this ordered pair 4, 4 work in both of those equations? So the first one was x equals 2y minus 4. Our solution said that x was 4, and it said that y was 4. So if we substitute those in and it works, then that's a solution to the first equation. So 4 is equal to 2 times 4 is 8, and 8 minus 4 is 4, and 4 does equal 4, so it works. We'll take a look at the second one, 2x plus y equals 12, and replace x with 4, and replace y with 4, and see if it works. So 2 times 4 is 8, and 8 plus 4 is 12, and 12 is equal to 12. It worked in both. 4, 4 is a solution. So to recap what we did here, the idea behind substitution is to get one of those variables by itself so you can replace it. You know what to replace it with. because x was equal to this, I can replace x with 2y minus 4. That gives you an equation with just one variable. You can solve that, find the answer for that variable, take that number, substitute it back in, solve for the other variable that you need, and then check and make sure that it works. Okay, we'll take a look at one more example here. The difference on this one is that we don't have a variable that's already by itself. So I have this expression 2x, or x minus 2y, that's equal to negative 6. Well, I guess if I saw an x minus 2y, I could replace it with a negative 6. Or if I saw a negative 6, I could replace it with x minus 2y. That's not very helpful though. So what we want to do is get one of these variables by itself. Get x equals, get y equals, so we have something to replace. It doesn't matter which one you solve for. I'm looking at this and seeing that the only step to solve for x would be to add 2y to both sides. And if I tried to solve for y, it would involve moving x over and dividing, and that's a little extra work. So I'm going to go ahead and take this equation, x minus 2y equals negative 6. I'm going to solve it for x, get x alone on the left side. To do that, I'm going to add 2y to both sides, and that's going to give me x equals negative 6 plus 2y. Knowing now that x and negative 6 plus 2y have the same value, I can take this expression, negative 6 plus 2y, and I can substitute that for x. Anywhere I see an x, I can replace it with this because it has the same value. So in that second equation, I see an x right here. I'm going to go ahead and replace that with negative 6 plus 2y. So I'm going to write it exactly as this equation, exactly as it is, with one change. I'm going to take out the x. I'm going to replace it with negative 6 plus 2y. Everything else will be brought down. Bring down the 4, bring down the plus 6y, the equals 4. We just replace the x with this expression, which we know to be equal. Now it's just a matter of solving for the only variable that's there, which is y. So 4 times negative 6 is negative 24, plus 4 times 2y is 8y, plus 6y equals 4. Got a couple like terms here, so combine those, and you've got 14y. I want to get y by itself here, so I'm going to add the 24 to both sides and get 14y is equal to 4 plus 24 is 28. I want to divide both sides by 14, so y is equal to 2. Now that I know that y is 2, I want to go back into one of these equations and solve for x. Now since I had already gotten x by itself here, it makes the most sense to go back to that equation, x equals negative 6 plus 2y, and replace that y with 2. So x is equal to negative 6 plus 2 times 2. So that's negative 6 plus 4. So x is negative 2. So it looks like our solution here is the ordered pair negative 2, 2. But I want to check that and make sure that it works in both. So that first equation, x minus 2y equals negative 6. Our solution says that x is negative 2 and y is positive 2. So we have negative 2 minus 4 equals negative 6. That works out to negative 6, which is equal to negative 6. It worked. Take a look at that other equation, 4x plus 6y equals 4. And replace x with negative 2, replace y with 2, and see if it works. So 4 times negative 2, that's negative 8, plus we've got 12 is equal to 4. Negative 8 plus 12 is 4, and that is equal to 4. So it worked. So to recap on this one, we weren't able to replace right away because we didn't have a variable equal to an expression. So we had to take one of the equations and rewrite it in terms of x equals or y equals. This one looked easier, so that's what we used. Added 2y, got x by itself. Made the substitution. Instead of x, we replaced it with something that's equal. This expression, negative 6 plus 2y, used parentheses there. Then solved for y, plugged it back in here, solved for x, checked it out, and it worked.